and indirect proof. Imagine a gate between fence posts A and B that has hinges at A and swings open at B. So picture a door or a gate. Here at A, it swings open, and this blue dashed line represents the arc of how the door swings. As the gate swings open, you can think of triangle ABC with side AC formed by the gate itself and side AB representing the distance between the fence posts, and side BC representing the opening between post B and the outer edge of the gate. Notice that as the gate opens wider, both the measure of angle A, so here, and the distance of CB increase. This suggests the Hinge theorem. So notice that as this door is opening, angle A is increasing and side length CB is increasing. And that leads us to the Hinge theorem. The Hinge theorem says if two sides of one triangle are congruent to two sides of another triangle, and the included angle of the first is larger than the included angle of the second, then the third side of the first is longer than the third side of the second. So, for example, here we have a diagram. Vx is congruent to RT. VW is congruent to RS. So two sides of one triangle are congruent to two sides of another triangle. The included angle, however, is different. So this angle is 88, this angle is 35. So by the Hinge theorem, we can conclude that this side, WX, must be longer than, WX must be longer than ST. So WX is greater than ST. And we call that the Hinge theorem. The converse of the theorem would be to make the reverse. Instead of starting with the angles, you would start with the sides and then go to the angles. What I mean by that is as follows. If two sides of one triangle are congruent to two sides of another triangle, and the third side of the first is longer than the third side of the second, then the included angle of the first is larger than the included angle of the second. So here, because this side length is 9, then that means angle F must be smaller than angle C. Here they put, which is the same thing as saying angle C is greater than angle F. Why is angle C greater than angle F? Because angle C is opposite the side length of 12 and angle F is opposite a side length of 9. So C must be smaller than F. That's the converse of the Hinge theorem. Now let's apply that. Given that ST is congruent to PR, how does angle PST, in other words this angle, compare to angle SPR? Well, if you notice, here we have two triangles side by side. They share side PS, so that is congruent to itself by reflexive property. So, hey, we can apply the Hinge theorem because here we have two sides of one triangle. We have triangle STP, and we have also triangle PRS. Notice I started with P because I started with S. And then I went to R, and then because it goes from S to T. And then T to P, so we went R to S. I'm just kind of reminding you how to name the triangles. Alright, so these are the two triangles. They're not congruent because TP is 24 and SR is, or RS is 23. So that means that if you look, angle S, or angle PST, is opposite the side length of 24. Angle SPR is opposite the side length of 23. So that means that angle SPR must be smaller than or less than angle PST. And this is the formal explanation, which I already explained here. Okay, moving on. Let's give another example applying this. Two groups of bikers leave the same camp heading in opposite directions. Each group goes 2 miles, then changes directions and goes 1.2 miles. Group A starts due east and then turns 45 degrees north. So group 1 went due east and then turned 1.2 miles. So it went east 2 miles and then it turned and went 1.2 miles. Group B starts due west and then turns 30 degrees due south. So the other group's going west and then goes south 30 degrees. Now if you look at these two triangles, we can form a triangle by going like this. We can move this arrow right here and it'll form two triangles. Let me redraw that so it's clear to you. 1.2 miles west and they went 2 miles east. The other group went 2 miles east but in the opposite direction and then went south 1.2 miles. And this is 30 degrees and this is 45 degrees. So we want to know which group is farther from the camp. Well, they share the 2 miles. They both did 2 miles, so they share that part. Then they both went 1.2 miles, so they share that length. So now we have the Hinge theorem. We have two sides of one triangle congruent to two sides of the other triangle, but the included angles are different. Well, this angle is 45, so this side must be larger than this side, which is opposite the 30-degree angle. So the group that did a 45-degree turn is going to end up being farther from the camp. So group A is farther. Okay, now let's do some guided practice. If PR is equal to PS and the measure of QPR is greater than QPS, which is longer, SQ or RQ? Well, they told us that QPR is greater, so the side opposite QPR has to be greater. So RQ is greater. If PR is equal to PS and RQ is less than SQ, so let's erase this because we have a different scenario. RQ is less than SQ. Which is larger, angle RPQ or SPQ? Well, let's put some numbers. Let's say RQ is 5. SQ would have to be, RQ is less than SQ, so SQ has to be maybe 7, as long as you make it a number that's greater. So that means this angle here is going to be larger than this angle because this side is larger than this side. So angle SPQ is going to be greater than angle RPQ. So this one's larger. Okay, and we'll skip number 3. And that's it for part 1 of 5.6.